Sorry about that. So the audio should be fixed now. Anyway, fill out the course evaluation if it eventually shows up. 750 out of 900 points have been assessed. Everything has been graded except for the final project and the final exam, which are next week. Right? So if you're taking option A, you should be working on it right now. Hack 14 and the project, those basically go together. Hack 14 has you designing structure to support this transaction system. And the final project is that you are producing several reports based on that data using searching and sorting techniques and algorithms. There's no collaboration on that, of course, and there's no collaboration on the final exam either. If you choose to do the final exam, it's worth the exact same amount of points, and it's going to be on Wednesday. You only have 2 hours to do it, though, instead of the last couple of weeks, and still 1 week left. Yeah?
So just to clarify, if we choose to do the final exam, we are now done with assignments. Hack 14 is not...
Yeah, you don't do Hack 14.
There's no Lab 14.
Nope, no, there's no lab. I mean, there is a Lab 14 and 15. I don't know if I put them on Canvas. You can check them out if you want. Lab 14, however, is going to require GTK. It's a windowing system and graphical user interface programming. Don't worry about it. And then 15 would require ODBC, open database connectivity, and we haven't covered either one of those topics because of the shortened 14-week schedule. So there is, of course, a lab hack session help session this Friday. The TAs will still be there. If you have questions, you can go ahead and go there and ask. Okay.
There is a unit on graphical user interface?
Typically, I would do like 1 or 2 lectures, and then we would cover GTK. It's just event-based programming, but there is a lab on it with you just make a calculator program, right? Using GTK. The final exam, I will be proctoring that, so I'll be, if you're choosing to do the final exam next week, 1 week from today, it's at 12:30 to 2:30, and we'll be up in PKI 311, just in case anybody needs a computer or a fallback computer. Otherwise, it's open book, open note, and required computer, because of course you will be coding in the exam. You may use any code that you wrote throughout the semester from a lab, from a hack, or that we were provided by in a lecture or something like that. So come prepared with some basic stuff, file IO, whatever you need to get the job done, okay? All right, so here's our final exam from last fall, right? Scott Frost here is trying to argue that they were the national champions in 1997 because he's going to want you to produce the following report. We're going to list out all of these NCAA teams, but only if they have 11 or more games, right? We're going to print out their win-loss record, their win percentage. So, for example, Nebraska was undefeated, 11-0, and so their win percentage was 1 or 100%. Rutgers down here, they had not a single win, so they were 0%, right? But we're also going to print out the point differential here. That Nebraska scored 329 more points than they scored against them. Right? We previewed this data last time. It's in 2 files. First of all, we have a teams file, which has 2 tokens on each line. We've got this what's called a UUID, a universally unique identifier, right? And then the name of the team. Right? And based on that universally unique identifier, let's find Nebraska. There we go. There's your universally unique identifier. What we can do is we can go to this other CSV file and see that they played a bunch of games. These are going to be the home team, identified by the universally unique identifier, the UUID, the number of points that they scored, there's the away team, and there's the number of points that they scored. So, for example, at some point Nebraska was the away team. They scored 49 points against, I think that this was Baylor we looked at or something, I don't know. And whoever scored that scored 21 points. We'd have to go back to the teams file and find out who that is. It was Baylor. So we're going to want to produce this report here, right? And all the details are, of course, in this write-up. Okay. I just gave you the quick rundown there. So suggestions on how to get started here. First of all, I'll point out that we also gave them some a starter code here. For example, we gave them a split function. We did the split function in class, by the way, if you want to review the video on how we did that. Basically, it just takes a CSV string, and then it splits it up into all of its tokens for you so that you don't have to do all the work. This one is chomps. It removes any trailing white space from the end of a given string. That might seem useful. And then we've got this free string array, a utility function that frees an array of strings that has n strings in it. Okay? All right. That's all we were given. And I've got started now, this Huskers file. Let's refresh there. And there's the Huskers file. Right? So we're going to want to include the standard library, right? .h. Of course, you're going to also want to include any documentation. Right? You will be graded on documentation, style, design, etc. Right? So this computes a report of the 1997 NCAA football season results. Right? And me. Right? There we go. ... Right? That's not going to be the important part here. Right? We're going to include the standard library. We're probably going to be doing some input-output, so stdio.h, right? And int main, int argc, char argv. Right? So for any one given team, we're going to want to keep track of a lot of things. We're going to want to keep track of their name, the number of wins, the number of losses, and of course we could always derive the win percentage by simply just going number of wins divided by the total number of games. And then, of course, the point differential here. So in other words, we're going to want to have the number of wins, losses, name, points for, and points against so that we can compute that difference. What is that screaming out to you to do? There are 5 pieces of data that belong to one logical unit.
We need to create variables for the win, or for the number of games, the wins, the losses, the points scored, and the points against.
And where would those 5 variables be for one team?
In
In
an array.
an array?
Or a struct.
A structure, probably, right? So let's go with a structure here, okay? I'm going to go ahead and put it into the utils file here. So how do we do a structure again? Type def. Struct, there we go, right? What should I call this? What is it modeling? A team, right? Sounds familiar. Baseball teams that you did in lab 11, I want to say, right? All right, so those 5 variables, the team name, which is going to be a string, name, right? The number of wins, int wins, int loss, right? You could go losses. I like the fact that there are 4 letters, so it all lines up nicely, right? What else? And why are those integers? Can you have 3.5 points or wins in a football game? No, right? In professional football, you can have a tie, and it does count as a half a win for the standings. That's not possible in NCAA. Yeah, I didn't think so. Right? Okay. What else do we want? Points for and points against. There we go. Okay. Let's take a look at that teams file again. There are 145 teams here, and we're telling you that so that you can go ahead and read that first line of the CSV file and initialize an array of that size. If you wanted to hard code that value, then that's fine too. We didn't count that against anybody, but we made that the first line so that you could process that first line. Right? So I'm going to go ahead and include the utils.h file. And my first step here is going to be to process the teams.csv file and create all the team structures in an array. Okay? So let's open up that file and read that first line so that we get the number of teams, int num teams. Right? let's open up that file. File star F, right? And I'm going to open a file. And what am I going to open? Which file am I going to open? Teams.csv. And I'm going to open it up for the purposes of reading. Right? Now, of course, you can check that, do some basic error checking here. If F is null, then of course we'll go ahead and print an error message and quit or something like that. I'll leave that as an exercise. And by the way, doing something like that, quitting or even printing something, that's something you do in the main function. It is not something you do in any other function, period. Okay, so file star F open, we're reading it. I need to read that first line. Read the first line. Dot, dot, dot. And convert it to an integer. Num teams is equal to, well, before I do that, how do I read that first line? F gets, okay. And where do I put it? I need a buffer, right? So char buffer, or buff, whatever. I'm going to make it 1,000 characters long, right? That is more than enough to hold any single line of this entire file or any single line of this file here. Right? Okay, that's where I'm going to put it. What's the second argument of forgets? The maximum number of bytes minus 1 that it will read so that you don't have a buffer overflow. And finally, the file that you're reading from. Okay? That reads in the first line. And now what I can do is say num teams is equal to, how do I convert a string to an integer? S2I, what was it? It's not string, it's alphanumeric string to integer. So it is A to I of the buffer, right? We're taking whatever's in the buffer, which is an alphanumeric string, and we are converting it to an integer. Right? That tells me how many teams, how many team structures I need, right? So let's go ahead and create the array, a dynamic array. Dynamic array to hold num teams, dot, dot, dot. Right? So I need a team star, right? Teams is equal to team star malloc. How many teams do you want? Num teams. And how many bytes does each team take? Size of team. There we go. Now I can iterate through the rest of the file. I could do a while loop here, right? While I'm not at the end of the file. If I use forgets, how do you know if you're at the end of the file here? It'll return null, right? If I was using fgetC, how do I, like we did on Monday, right? To get all the way to the end of the file, what does fgetC return when it gets to the end of the file? EOF, right? Okay, but I don't have to do either one of those in this case because I know exactly how many lines I want to read. Right, let's take a look at that teams again. Right? 145. There are 145 records to read, and I only read up to line 146 then. Right? So that's why we gave that to you in the first, that gave that to them last semester in the first line. You could use a regular old for loop now. For int I equals 0, I is less than num teams, I plus plus. I'm going to read the line, process the line, and create the team, the ith team. All right? So how do I read the line again? Same exact thing as up here. I'm reading it into the buffer. Now I want to process the line. Remember, what does the line look like? Over here in the teams file. I've got a UUID, and I've got a name, separated by a comma. That's CSV data, teams.csv. It's exactly what it is, right? Thankfully, guess what we gave you? A split function that will take a string, split it across a delimiter, and tell you how many tokens it ended up having. Do we want to see how that works? Let's go into the .c file here. First of all, what does it do? It goes through and counts up the number of delimiters so that it knows how many tokens there are. Then it sets up a result for the number of delimiters plus 1. Why? Because if there's 1 comma, then there are 2 tokens to be read. If there are 2 commas, then there are 3 tokens to be read, etc. And then it goes through it again. strdup is a deep string copy that's part of the standard, not the standard library, but an extension. Right? And then we end up freeing this this temporary string that we were working with, telling you how many elements are in that array, and then returning the result, which is a char star star, which is a 2-dimensional array. Right? It's a 2-dimensional array of characters, or put another way, it is an array of strings.
So that function just goes through and you put in your delimiter, and then it splits it up, and it puts the 2 separate strings into an array, or however many there is.
Yep. This result right here. Yep. And I think we did a version of this in class, if I'm not mistaken. You can go back to the length split was on the hack, and that's why I did this kind of split in class. But in any case, I'm going to use it, right? Because I was given it, right? So I'm going to go ahead and split this, and I'll call it char star star tokens, and I'll split whatever is in the buffer, right? And I will expect 2 tokens here, right? And so I need to pass that in, right? Int num tokens. And I'm going to be splitting along a comma here, and I want you to tell me how many tokens you gave me. Tokens. Right. Why did I put an ampersand in front of num tokens? Because it expects a pointer, right? And is going to be, let's read the documentation here. It's a utility function that splits a string into an array of strings along a provided single character delimiter. The last parameter is used to inform the calling function of how many tokens it found, and thus the size of the returned string array. Right? And so we have to pass this by reference in order to fill the bucket, right? Passing by reference means that you're giving a bucket, a shared bucket, and they can access what's in the bucket, they can change what's in the bucket. Right? So what we're doing is we're getting back the number of strings here. We can do a basic error check here, right? If num tokens is not equal to 2, we're expecting exactly 2 tokens, right? We can say printf error on line, whatever the line is, %s and the line, buffer, there. Right, we're expecting a UUID and a name. So now let's create the ith team, or actually instead of creating it, let's initialize the ith team. So that tells me that, yeah, great, you designed this, the structure. What else should you be doing along with designing that structure? Probably writing some functions to support using that structure. So one of them that I'm going to use is void init team. Right? That takes all of these things, maybe something else too. We'll have to maybe redesign it. Const char star name, and we could take the wins, we could take the losses, we could take the points for or against, but do you see any of that data in the teams file here? Nope. So let's not worry about that. Let's worry only about just the name for now. Right? And if it's initialized, I'll also take in a team T. There we go. Is that the correct way of handing off a team to this init team function? Nope. None of the examples that we've looked at, airports, baseball teams, RSS feeds, what else? Transactions for your project. What else did we do? Faculty, students, et cetera, right? At least a half a dozen examples now. How have we passed in the team in order to initialize it? As a pointer. Right? So T's name is equal to, do I have a deep copy string? Nope. But that's a gift I can give to myself, right? Again, you can always go to your old code and pull out old functions that you've written or that we've provided or something like that and use them. So char s deep string copy char star const char star s. And typically I would go ahead and go back to my old code and cut and paste that, but I don't have that luxury here. I'm just going to go ahead and write it anyway. Right? How do we write it? That's a good review for strings. Char star copy. I make a call to malloc. Right? And then how big does it need to be? Okay, size of char. That's the number of bytes a single character takes. strlen of s. Is that it? So hello, 1, 2, 3, 4, 5, plus 1. Why? For the null terminating character. There we go. So I've initialized enough space for it. Now I can copy it, strcpy, into the copy, the original string s, and return the copy. Okay? And now I can use that. Where do I want it? Over here. Oh no, sorry. We're still working on the init function. Oh, you know what? I should have put that somewhere else. But oh, that's all right. I'll go ahead and copy and paste this once we're done with it. All right? Name. There we go. I'm just doing a deep string copy of the name. What about the rest of the stuff? T's wins. What should I initialize that to? Their losses. 0. Why 0? Because I'm going to go to the other file in order to get that data. Right? I don't have that data yet. So initializing these to sensible defaults means setting them to zeros. Okay? T points 4 is equal to 0, and T points against is equal to 0. Why am I using a arrow operator on all these things? Because it's a pointer, right? If it were a regular old team, then you would use a dot operator. At this point, I'm thinking, wait a second. We're ignoring this token right here, this UUID. Should we be ignoring that when we go to the games? Nope. Do you see the name of the team here at all? Nope. We're going to need that UUID here. So back to the drawing board. No big problem. No big deal. We can go ahead and add that back in. Char UUID. And we can take it const char UUID and do a deep copy of UUID. If you're not familiar with UUIDs, again, it uses a cryptographic hash function along with some randomization in order to generate a universally unique identifier. The probability that at any one point or at any time in the entire history of or future or history of man, the probability that any two computers generate the same UUID is infinitesimally small, right, because of the way that it's done. Okay, let's go back over here to our main Huskers. So let's initialize the ith team. Init team, and I'm going to pass in something. Right? Remember that we designed this to take in a team pointer, the UUID, and the name. And those are my tokens. Right? Tokens sub 0 is the first one, UUID, and tokens sub 1 is the second one, the team name. How do I pass in the ith team, though? I called it teams. How do I get the ith team? Teams sub I. Now think about that, though. The ith team is a regular old structure, right? And does this expect a regular old structure? Nope. Pointer to a structure, so ampersand. Excellent. And by the way, this doesn't belong in the utils.h file. It belongs where? The header belongs here, and I'll put in a to-do documentation. But the definition belongs over here in utils.c. Okay? At this point, I'm confident that I have read in all the teams. So let's iteratively test this thing and make sure that it actually works. Well, first of all, what should I do with that file now that I'm done processing it? Close the file, right? And let's go ahead and test that I've actually read all these teams. For int I equals 0, I is less than n, num teams, I plus plus. Let's go ahead and print out the ith team. Printf, %s for the team UUID, and %s for the team name, and then end line. So teams sub I, how do I get the name of, or the UUID of the ith team? Is it dot or is it arrow? It's dot. Why is it dot in this case? It's just a regular old structure at this point. It's not a pointer to it. Right? UUID and team sub I dot name. There we go. Let's go ahead and make sure it works. GCC utils.c and huskers.c, and turn on all the warnings. Tell us if there's anything wrong. There's plenty wrong. Huskers 36. 35, sorry. Oh. Comma instead. Is that it? Yep, okay, good. Let's run it. If it works, we should have read in that file on all 145 teams. And it should match this teams file here. Miami, Florida is the last one, Arkansas, right? And they have a UUID of 06F3B, 06F3B. Looks like it works to me. Let's make sure that we're checking the first one too. North Carolina State, FFE8D, dot, 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 dot. It looks good. Right? So I'm going to go ahead and close this CSV file at this point because I know that I'm reading that incorrectly. I'm reading it into memory correctly, not incorrectly. I'll go ahead and get rid of that code. Although maybe I should have put that code somewhere to reuse it later on. Right? Okay. Now what I need to do is I need to process the teams.csv or the games.csv file. Dot, dot, dot. Okay. That's going to have 4 tokens on each line. The first line will be the number of lines that you need to read again. Right? After that, there will be 4 tokens on each line. This is the home team UUID, the home team score, or sorry, the away team. Away is always first. Then the home team score, or home team UUID, and then the home team score here. Okay? Let's go ahead and read in those values. Right? So int num games. Right? There we go. And let's open the second file for processing. Dot, dot, dot. Fopen, or I'll just reuse that variable from before. F is equal to fopen. And we're going to open the games.csv file for the purposes of reading. Right? Read in and convert the first line to know how many lines you should actually read. Right? So num games, here, buffer forgets into buffer at most 1000 F, right? And then num games is equal to a to I of buffer. There. And same, it's the exact same pattern here, but instead of num teams, it's going to be num games. So for int I equals 0, I is less than num games, I plus plus, I will read the line, right? Process the line by splitting it into 4 tokens, right? And then process the data in the line, dot, dot, dot. Let's do the easy parts first. How do I read in the next line? Same thing again. Forgets buffer 1000 F. How do I process the line? Well, I need a num tokens again, int num tokens. And I'm going to reuse that same function that we used up here, right? This thing right here. And if the num tokens is not equal to 4, then we know that something is up. Up here, we were looking at 2, right? Down here, we're looking at 4. Why? Again, it is the UUID, comma, the away score, comma, and then the home team, and then the home team score here. Okay. All right. Now I need to process the data on the line. Now for that, I'm going to actually rename my variables, right? I've got 4 tokens here which are all strings. So char star home away UUID is equal to the first token, tokens of 0. Char away score, away score, that's just going to be an integer, right? So I'll go ahead and immediately convert that. A to I of tokens of 1. And then char home UUID is equal to tokens of 2. And then int home score is going to be A to I of tokens of 3. So I've got all 4 of my pieces of data now. And I've got them in sensible variable names, so I'm not thinking, what was the 4th token again? What was the 3rd token? And by the way, you need to subtract 1 because indexing starts at 0, et cetera, right? Now I've got meaningful variable names here that I can work with, right? What I need to do now is find the away team and ... increment their score and win or loss ... Then I'll do the same thing for find the home team and ... increment their scores, and by the way, their scores, because points for and points against, and win or loss ... So basically, this is the exact same thing as this. So let's focus on the first one. I need to find the away team, okay? How do I find the away team when they are stored in this teams array right here? Say what? Teams of I? Well, what is I at this point? I is incrementing on a completely different file, 642, right? I actually want the team, right? What I want is something that looks like this. Team, away. I want a pointer to it because, but you could do it with a regular if you really wanted to, right? I want to find the team with UUID equal to away UUID in teams, ... So what could I bring to bear here that we've been covering over the last several weeks? Searching and sorting, right? That's what I find something. Search, sort, right? So I could roll my own linear search algorithm, but I like using what's built into the, what would that look like, by the way, right? You would go through each team, and if that team's UUID matches the away UUID, then you found what you're looking for. There you go, right? On the other hand, what's a better way of doing that? B-search, okay. So if I'm going to B-search, binary search, the teams array, then what order do I need to sort it in? Order of UUIDs, right? So sort the teams array in order of UUID, ... Help me out. First of all, what's the sorting function that's built into the standard library? QSort. What are the 4 arguments to QSort? The first one is the thing you want to sort, teams. The second one is the number of elements in that array, teams. The third one is yep, that's the 4th one. So let's go with the 3rd one first, though. What? A number of bytes that each one takes. So that's going to be size of team. And then finally, the comparator, CMP by UUID. Right? Gee, I wish I had something like that. So what does that tell you to do? Create your own. To do. Documentation. Right? Otherwise, I need to create a comparator called CMP by UUID. What's its return type? Int, right? And what does it take as two elements? Does it take a team A and team B? Okay, does it take two strings? Const char star A, const char star B?
That
Nope.
looks like what I did last night, so I think that's it.
Is that a comparator though? It's only a comparator if and only if void and void. strcmp does strings, but that one's already done for you. You don't need to write that, right? Okay, let's take that over to .c and implement it. The first step in any comparator is to to typecast it into const team star x is equal to const team star A and B. Oops. And now once I've got two teams in my hand, now I can compare them by UUID by calling strcmp on the two strings, right? So return strcmp of x's UUID and y's UUID. It doesn't matter if we go top to bottom or ascending order or descending order, as long as we're searching along using the same comparator. Okay. There we go. Go back over to Huskers here. Now it'll be sorted. Excellent. How do I find it now? I want something that looks like this. So find the team with UUID equal to away UUID in teams. So I need a B search algorithm. Now how do I call B search? The first argument is the key. I don't know how to do the key yet, but otherwise the other four arguments are exactly the same as QSort. That should be a cut and paste right there, although you shouldn't cut and paste. Right. Yeah.
You talked about SRCMP, but like you mentioned it.
Right.
If
Could you use that as a comparator?
yes.
The answer is no with a but, or yes with an if, whichever one the case may be. All right, so let's take a little bit of a digression here since we've got plenty of time. So if you check out the textbook for the course with a C section, let's go to the C, sorting, searching, there we go. I think it's here. There we go. If you wanted to have a comparator for strings, well, first of all, you have to have that signature, right? It has to be const void star. So how do you end up using strcmp in that? All in one line, you can do something that looks like this. Now, if you want to know the process of what it's going through there, it's doing something, or here it is, right? These are all the conversion types all the way down until you finally pass it off to strcmp, right? So if you're interested in that, read all about it. But otherwise, if you just want a quick and dirty solution, it's not a dirty solution, just a quick solution here, cut and paste that, and you have made strcmp into a pointer strcmp. Basically, what happens is when a string gets handed off to the comparator, there are ampersands in front of it. So the strings become char star stars, 2 stars, right? Because you have a pointer to the array, right? And so what you have to do is you have to typecast it like that, but then you have to immediately dereference it because you don't want the pointer to the string, you want the pointer to the string. So dereference this to jump over there. Right? Otherwise, don't worry about it and just use the pattern that I've given you so you don't have to worry about it. But if you're really, really interested, there's the full Monty of what it looks like. Right? All right. So how do I pass in a key here? Well, first of all, I need to create a key, right? So let's go ahead and create a team called, and I'm going to want 2 keys here, so I'll call it an away key. There we go. Right. Away key. How do I initialize something? How do I initialize a structure using just the curly brackets for a quick and dirty instance of it, right? Well, first of all, I want the UUID, right? The name, the wins, et cetera, et cetera, et cetera. Most of those things don't matter. So you could just go ahead and go with an empty string, the number of wins, the number of losses, the points for, the points against, those will all be 0 because I'm not searching on them. The only thing that matters here is the UUID. Right? So how do I get that particular UUID other than mashing my keyboard? The away UUID, you just simply put it in there and you can then that'll work. Right? There's the away key. Is that correct? Does bsearch take a regular old structure? Nope. It takes a pointer to a structure. So how do I take a regular old structure and change it into a pointer to a structure? Ampersand. All right, there we go. Same exact thing for, well, here, we're not done yet. I'll hold off here. So now I've got the away team. What do? I've got their score. I've got the away score. I've got the home score, and whether or not they won or lost. Right? So away score, points against. Right? Points against. I want to add whatever the home team scored. Right? Because they're the away team. The home team scored 5 points. They scored 5 points against the away team. Away points for plus equals however much they scored, away score. There we go. Now how do I tell if the home team won or the away team won? Points for, or away points, away score is, okay, then they lost, right? Is less than the home score. So home, except I don't have a home here, right? Home wins plus plus, right? Else if away score is greater than the home score, then the away team won, so away wins plus plus. And by the way, if the home team won, then the away team lost. Right? And if the away team won, then the home team lost. Okay? I like that, and with an else maybe here, printf, something seriously went wrong, ... Again, you can't have ties in NCAA football. So what's the record for the longest game?
Like in terms of like time?
Yeah, OT, right?
There's
What?
most recent was
9 OTs?
yeah.
Oh, jeez.
I
Okay.
think that happened this
It
year.
happened, yep, October 23rd, 2021,
For
60 minutes of regulation, 2 normal overtime periods, and then 7 exchanges of 2-point conversions.
God.
Illinois
And the 2-point conversions, they don't time those anymore. They don't have a clock for those.
I think they changed it to where it's like a shootout where you do like a 2-point conversion
after 2 overtime periods.
yeah.
Shootout.
It goes into like a shootout of 2-point conversions basically.
God, I remember the Blackhawks. What was it? The 2012 season. Every single playoff game almost had an OT on it, and that was before the shootout. So there was one game with 6 OTs, and each OT was like a full 15-minute period. I was watching games into 2 a.m. in the morning. It was terrible.
2019, 2020, Texas and Oklahoma went to like 8 overtime.
Well, it's better than a tie. All right. So anyway, there's the away. How do I get the home team? Well, copy paste, although you shouldn't do that. Home key, home points against, and then here we have to switch these around, right? Away score and home score. There we go. Okay. Now, if I was successful at this, after I'm done with this loop, I should be able to print this all this stuff out and see and fully and see all of the data, and then verify, does that look right? Right? So for int I equals 0, I is less than num teams, I plus plus. Let's try to get this formatting immediately, right? So we're going to have the team name, the wins and losses, and then the point differential here. Right? And if we can find Nebraska and match this line right here, then we know that we're bug-free, right? And also no seg faults or anything like that. We can also compare it to Michigan and know that we're bug-free or whatever. So team, win-loss, percentage, and point difference. So printf, %s, that's the team name, %d, let's go ahead and format this stuff immediately with 30 left justified, 2 digits for the number of wins, losses, 2 digits for the number of wins, losses, then in parentheses here, %f for the win percentage. Looks like we only go out to 3 decimal places, so 0.3f. And then what else? Point difference. So %, I don't know, 3D, end the line. Okay. What are all those things I'm printing? Teams sub I, their name. Teams sub I, their wins. Teams sub I, their losses. Right? Teams sub I, their win percentages. But did I store that in the structure? Nope. That's okay. Win percentage is just number of wins divided by number of wins plus number of losses. Right? There we go. Before I go on, is that correct? Number of wins divided by wins plus losses. Yeah, what's going to happen? These are integers. Integer divided by integer is going to be an integer. So it's only ever going to be 0 or 1. But if you typecast at least one of them, then it should be good. Right. Teams sub I, and then the point differential here will be an integer, so we don't have to worry about that. What is it going to be? Points for minus points against. There we go. And then we exit. Before I do that, I should have closed that file. So close F. All right. Take care of some issues here. Team. Oh, okay. Yeah. Should I have used the arrow operator here? Dot Y. It's not a pointer anymore, it's the ith one, which is just a regular old structure. And so all of these should have been dot, 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 dot. There we go. Save that. Still a problem here. What? When? Oh, these should be commas, commas, commas. There we go. Now again, if this is correct, we should at least have that report not in the order that we want, but in the order that we read it from the file. So let's find Nebraska here and see if it was correct. 11-0, 100% team win percentage, and 329 points. That looks about right. Where's Michigan? Not Eastern Michigan. There's Michigan, 11-0 and 203. Right? That's correct. Let's look for somebody else. Louisiana. 1 and 10, negative 377. So mine's Louisiana. There we go. 1 and 10, 377. I'm convinced everything works. But is that the report that we want? It's not in order. It's not in win percentage order. So what do we need? We need to sort it. Q sort, and so we need another comparator, right? Teams, num teams, size of team, and then a new comparator. That new comparator will sort it by win-loss percentage, and in the case of ties, it'll break those ties by looking at the point difference here, right? So lots of logic in that one. CMP, win percentage, point diff. Remember, there are only two if you only take a few things out of this course, other than, you know, core programming skills, remember all the quips and acronyms and stuff like that too. What are the only two difficult things in computer science? Cache invalidation is the first one, and naming things. That one's good enough. There we go. That is not my quote, by the way. I don't know who gets credit for that. Const void star A. Const void star B. Right. And a return type of an integer. To do documentation. Okay. All right. First thing I need to do, I can cut and paste this guy right here. There we go. Now that I've got these teams, I need to look at their win percentage. So let's go ahead and compute those independently. Double X win percentage is going to be X's wins divided by X's wins plus X's losses. Now check myself here. Should I be using those arrow operators or not? We've got a team pointer. So when we've got a pointer to a structure, yes, we use arrows. Y, 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 and Y. Now, if X's win percentage is greater than Y's win percentage, then X should come first. And so since A and B, X and Y, they're in order, I return something negative. Else if X's win percentage is less than Y's win percentage, then I should return X, Y comes first. So I should return what? Something positive. Else, we have a tie. All right, tie in win percentage. Not tie as in what a tie in a game. So we need to break that tie by looking at their point differential. Right? By the way, why didn't I put equals equals as the first or the second condition here? Because these are floating point numbers. 1.0 is not necessarily equal to 1.0 if there's if it's 1.00000000001, right? That is not equal to 1.00002, right? And so using the equal sign on floating point numbers is not a good approach. In fact, when you did testing, we told you not to do that, right? What kind of function did you use to say, here's one answer, here's the expected answer, are they equal? Is it correct? Is it close enough, right? And we gave you is close functions. Is close, this minus this, the absolute value of their difference, is it less than 0.00001, right? If so, then for all intents and purposes, they're equal, right? That's why we're not using equals equals here, because it does not work on floating point numbers. Right? So tie and win percentage, resolve the tie using point differential. Right? So X's point diff, int X point diff, is going to be X's, what is it, points again, points for minus X's points against, and Y's point differential is equal to Y points for minus Y points against. There we go. I've got the 2 point differentials. I told you always to avoid the difference trick, right? So if I just do a diff here of x point diff minus y point diff, right? And I return that diff, right? If it's positive, negative, or 0, the difference will tell you what it is. Now, I told you to avoid the difference trick because of large numbers. 2 billion minus negative 2 billion is positive 4 billion. Can you represent positive 4 billion with a integer? Nope. That's overflow. It becomes negative and gives you the wrong answers. Does any team in the NCAA in any one season have over 1 billion points? I don't know what the biggest blowout ever was. You can look up that record too. 77-3? Oh, it's got to be more than that. Some SEC team versus some scrub non-conference team or something. I don't know. Right? It's got to be.
Let's find out.
Keep it to Division I. Anyway, it's okay in this case because the
94 points.
94 point difference. Did they shut him out?
143 to 49.
143 to 49. Terrible defense right there. They allowed 49 points.
Yeah, let's see. This was. Wait, this is basketball. Hang on.
Okay.
That wasn't right. I knew that wasn't right.
But still, 49 points for a basketball.
Oh no, this is worse. 1916, Georgia Tech versus Cumberland, 222 to 0.
22 to 0.
Now, granted, that's over 100 years ago.
Wow. Okay. Anyway, there we go. Yes, defensive touch. Every ball possession was a touchdown by one of the other teams, by one team. All right. Anyway, I want to do Q sort before I actually print them out because I want that report. Let's see if that works. GCC, run this. There we go. And does that look right to you? Well, certainly I've got all the teams, undefeated teams here, right? Cal Poly, they were number 1 in 1997 with a grand total of 3-point differential. What's the problem there? We're not ignoring teams with the same number of wins, right? In the handout, we direct you to only include teams that have played at least 11 games. So yeah, Rutgers has 11 losses and Huskers have 11 wins, but somebody with only 1 game, we're going to ignore them. So I can just put in if here, right? If teams of I dot wins plus teams of I dot loss, right, is greater than or equal to 11. I think that was the threshold we defined. Then print it out. There we go. And indent. Okay. There we go. Try that again. All right. Now we're getting win differential zip here of 1, 1, and 1. Okay. That looks okay initially, except that is that the order that we want? Michigan on top of Nebraska? No, we don't want that. Right? What's the issue here? My comparator.
Is it only going by percentage and not by?
Well, it's going by win percentage.
And then it's going in alphabetical order of teams instead of.
Not necessarily alphabetical order of teams, but let's just take care of the first 2 here. My point differential. Is that correct? X, say, has 5 points, and Y's point differential is 0. Who should come first? X. But 5 minus 0 is going to be positive, giving you the wrong order. So, swap these around. That looks a little bit better. Still not 100% though. There. Nebraska, and Michigan. Right. That looks a lot better. But the rest of the report here, Florida State, are they third? Yeah, technically. And then Kansas State? Kansas State's not there. Why do we immediately go to Iowa? Huh? Kansas State is going to be somewhere down here, right?
Kansas State was the top, I thought.
Well, there's Arkansas. Kansas State should be up at the top, yes.
We're now going by
Yeah. Something's going on here. I don't necessarily see what it is off the top of my head here. Wins, wins, wins. Loss, loss, loss. Y win percentage, X. For some reason, it's jumping off onto the point differential here and not getting these two. Does anybody see what the issue is? Why? Anybody online too? X. Huh. I'm not seeing it immediately here.
It is jumping over the win percentage, just going to win differential.
Yeah, that's what I'm seeing too here. If, else if, I've got everything lined up, right? Yeah, and yeah. Points for, points against, point diff. X, Y, X, Y.
Are wins and losses integer values?
Yeah, they are.
Would you need to cast that?
Oh. Wait, how do I get back to where I was? Damn it. Get rid of that. Get rid of that. And good. What's going on? It's either one, and there are only two undefeated teams. Everything else is what? Despite us printing it out correctly, it's all going to be 0, and that's why it immediately goes to win differential, or it looks like it's going to win differential. Of course, 270 should come before 203 if you were just going by win differential here. So, double and double, duh. I wish that there was a warning flag for that too, but anyway, loss or truncation or something like. Programming language like Java does not allow you to do implicit typecasting like that. You have to do it explicitly. All right, give myself some more room here. Rutgers at the bottom. That seems right. And Nebraska at the top, Michigan, Florida State, Kansas State, Washington State. We only gave you a small portion here. Louisiana, Illinois, Northern Illinois, and Rutgers. And that looks correct too. Louisiana, Illinois, Northern Illinois, and Rutgers. So 3, what is the antonym of undefeated? Defeated. Unwinned.
Is that
Winless.
Louisiana as in LSU? No,
That's not LSU, no. Not all of these teams still are in Power 5, I'm sure. Frankly, I don't think Rutgers was in a Power 5 at the time either. They're in the Big Ten now. I don't know what they were before, but there we go. Yay! It's just data. By the way, I mean I've changed this year over year. It's not always sports, so if you're not into sports, fine. The year before this, I think it was Pokemon. The year before that, it was something else. They're all exactly the same, or a very similar flavor of process this data file, produce this report. Process this data file, produce this report. All right. Any questions? No? So another caveat here is when I gave this last semester, it was with an online hybrid mode. So we gave them a 24-hour window. Your exam should not be this long, right? So it took me speaking while we were doing it and debugging and stuff like that. What did it take us? Maybe an hour? So in general, the way that I write tests is if it takes me an hour, then it's going to take a student maybe 4 hours. So when I take the exam, I have a multiplier of times 4, and that allows me to cut back or add more starter code or add more helper code or something like that. Like with a TA, I usually do a multiplier of 2 or something like that. So if a TA told me, well, it took an hour for me to do it, then well, it'll take you 2 hours to do. It'll take a student 2 hours. They've not reported back to me how long it takes them because they haven't done it yet. But you can encourage the TAs to answer my calls to actually do the final. Right. So we know how much more to give. All right. I anticipate a lot of people will do. 2 people have already done the project. Hopefully, a lot of other people will do the project so that they're not, stuck in a test or exam or whatever. So, how many people plan on doing just the final? Oh, everybody here. Okay. All right. Never mind. I will see you all on Wednesday then, next week. Otherwise, same office hours throughout the rest of the week. No office hours next week at all for anybody. All right. But of course, I will be available on Piazza.
From the lab room.
Say what?
The final will be
Yeah, PKI. What was it again?
311.
311. PKI 311. All right. All right. Good luck on the rest of your finals if you have any.